The following is the details and objectives of this course. Please read it carefully, and start the course. Public concern about the environment is higher today than ever before. People want cars that are simple to operate and provide enhanced comfort. These demands have driven the relentless development of new vehicle transmission technologies. Most recent cars are equipped with 6-speed transmissions. These days, 6-speed transmissions are commonly installed in mid-sized and compact vehicles. When discussing an automatic transmission, most people assume that it is a 6-speed transmission. Compared to 5-speed automatic transmissions, this new 6-speed automatic transmission increases acceleration performance by 3% and increases fuel efficiency while cruising by 5%. Click the tip to see the main specifications of this transmission. Let's look at how the transmission functions with each engine. Lambda 2 engines come equipped with large transmissions, such as the A6LF1, A6LF2, or A6LF3. Theta 2 engines use medium transmissions, such as the A6MF1 or A6MF2. These transmissions are known as Lambda 2 6-speed automatic transmissions and Theta 2 6-speed automatic transmissions, respectively. The following tables show the main specifications of each engine. The core technologies of front-wheel drive 6-speed automatic transmissions can be classified as follows, depending on their features. Click each item to find out more. To increase fuel efficiency, the FWD 6-speed auto transaxle employs a one-way roller clutch. This reduces drag torque by about 20% when compared to a sprag clutch. It also uses a torque converter with slip lockup control to enhance fuel efficiency and NVH. The torque converter clutch controller controls slip and direct coupling based on the vehicle speed and the opening angle of the APS, thereby increasing the efficiency of the torque converter. It also enhances both fuel efficiency and NVH. In order to make them easier to maintain, 6-speed automatic transmissions have a closed side gear to prevent the oil from leaking out even when disassembled. Furthermore, it uses permanent oil that does not need to be changed. To increase fuel efficiency, the FWD 6-speed auto transaxle employs a one-way roller clutch. This reduces drag torque by about 20% when compared to a sprag clutch. It also uses a torque converter with slip lockup control to enhance fuel efficiency and NVH. The torque converter clutch controller controls slip and direct coupling based on the vehicle speed and the opening angle of the APS, thereby increasing the efficiency of the torque converter. It also enhances both fuel efficiency and NVH. To enhance shifting, front-wheel drive 6-speed automatic transmissions use a hydraulic deviation adjustment valve body to precisely control the oil pressure. Unlike conventional 5-speed automatic transmissions that use a VFS that only controls the line pressure, 6-speed automatic transmissions employ a VFS that can control the entire hydraulic pressure within the valve body to enhance the feeling when shifting. It can flexibly control the oil pressure in the 4 to 16 bar range, thereby increasing fuel efficiency. Compared to the 5-speed A5HF1 model, the largest 6-speed automatic transmission weighs 12 kilograms less, features 62 fewer parts, and is 41 mm shorter. Click the next button to see the differences between the FWD 5-speed auto transaxle and the FWD 6-speed auto transaxle in detail. To achieve a compact and lightweight design, front-wheel drive 6-speed automatic transmissions employ an ultra-flat torque converter. Now we will learn about the following components. Click each item to see more details. The valve body consists of 3 parts, the inner, middle, and outer valve bodies. This transmission uses different types of planetary gears. The front and middle planetary gears are simple gears, while the rear planetary gear is a double pinion simple gear. The paracoid oil pump increases the volumetric efficiency at low speeds. The one-way roller clutch is activated in first gear, to only control the LR brake in one direction. The LR brake operates in reverse and first gear. The 26 brake operates in 2nd and 6th gear. The UD brake operates in 1st, 2nd, 3rd, and 4th gear. The 35R clutch operates in 3rd, 5th, and reverse gear. The OD clutch operates in 4th, 5th, and 6th gear. Now, click the next button to view a full screen image of each component. This table shows which components are activated in each gear. Take a close look to understand how the components interact. The gear ratio of the transmission in 5th gear is 1:1. Let's pause for a moment here to take a pop quiz. Read the following statement and select O if it is correct and X if it is incorrect. In this section, we'll learn about the input and output elements of the transmission. Take a look at the screen to understand how the system works. First, let's go over the input elements. Among the input elements, we will focus on the inhibitor switch, the oil temperature sensor, the input shaft speed sensor, and the output shaft speed sensor. The inhibitor switch is located on top of the transmission and connects to the shift lever. This switch inputs the shift lever position set by the driver and the TCM. In short, the inhibitor switch monitors the shift lever position. The input method of the inhibitor switch is a slide contact type. The switch combines the 4 signals to input the shift lever position in the TCM. As shown in the figure, the inhibitor switch combines the signals to indicate the code numbers that represents each gear position from P to D, and transfers the code combination to the TCM. In addition to this, the inhibitor switch does not consider the shift lever position between gears, for example, PR, or neutral D to be a failure. The oil temperature sensor, OTS, is mounted on the valve body. It is capable of measuring temperatures between -40 degrees Celsius and 150 degrees Celsius. The oil temperature sensor is a NTC thermistor, so the resistance decreases as the temperature increases. This table shows the resistance of the oil temperature sensor at various temperatures. Refer to the table when performing maintenance. When the oil temperature sensor fails, the fail-safe mode activates and the TCM assumes the oil temperature to be a constant 80 degrees Celsius. Therefore, the transmission cannot learn the driver's preferences. This sensor plays an important role in deciding when to activate the damper clutch of the torque converter. The input shaft speed sensor detects the turbine RPM and the input shaft RPM at the overdrive clutch retainer. If this sensor fails, the shifter locks in 4th gear and fail-safe is activated. Therefore,